So, partial factoring, okay? What we do for partial factoring is we identify what the y-intercept would have been, which would be 0. If I substitute 0 in, I get my y-intercept. And I find I'm looking for the value of x that corresponds with having a y value of 7. And so that's what I substitute in here. Okay, I go 7 has to equal x squared plus 8x plus 7. And then I can subtract 7 from both sides. I'm going to get 0. It's x squared plus 8x. Okay? And 0 is equal to x times x plus 8. And we're in an agreement. That spits out one of your x-intercept, or not x-intercepts, one of the values of x that correspond with the graph being at 7. It's x equals 0. It also spits out the other one. X plus 8 is equal to 0. And so the other x value where the graph is at positive 7 for a y value would be x is equal to negative 8. Okay, those are your two values of x that are at a height of 7. And then if I'm interested in writing something from standard form into vertex, we could have completed the square in the past, but this is a little bit faster, I think, because I can find the axis of symmetry. Oops. Which is going to be the middle of 0 plus negative 8 divided by 2, which is going to be negative 4. I'll just write it down, save space. Okay. Then you can find the vertex. You can find the vertex by evaluating the function at negative 4. Get negative 4 squared plus 8 times negative 4 plus 7. So that'd be 16 minus 32 plus 7. Okay, so 16 take away 32 is going to be negative 16 plus 7 should be 9, right? Negative 9. So the vertex should be negative 4, negative 9. And if I write that in vertex form, okay, that's your partial factoring process. Okay, a little bit quicker than completing the square. Definitely nicer, right? 100% nicer than completing the square. Quicker could be up for debate, but I don't have to deal with any like 7 divided by 2 squared, any of that nonsense. I don't have to deal with that. And then the expansion of an a value back in, I don't have to do that. It's a nicer process to find the vertex. Probably a bit equal in terms of length of work, but the work's not bad. A little difficult to make an error through this, I think. Okay, so let's talk about whether or not this quadratic has roots. Maybe what we should have done is put producing, well, no. Let's talk about where does the vertex lie? Where the vertex is, like if I drew myself a little sketch, right? I know the vertex is below the x-axis at negative 4, negative 9. That's down here somewhere. Okay, and then I know that the quadratic's opening up. Everyone in agreement? So if the vertex is below and opening up, I'm going to have 2 solutions. It's going to look something like that. Okay, so we should expect, I don't know what they are. I didn't ask you what they were in this, and at any point of this question. You could find them, but I didn't ask you what they were. Expect 2 solutions or x-intercepts. Because the vertex is below x-axis and opening up. Okay, are we okay? So let's produce a graph now. What point do we have for sure in my identification of stuff? I know the y-intercept for sure. The y-intercept is going to be at 0, 7. That's that c value. So I can plot that one. I'm going to use that to my advantage, actually. So 0, 7 is going to be right here. Okay. What else do I know? Gabe?
The vertex.
I also know the vertex. That's good. So the vertex is at -4, -9. Right here. Sophie? Yeah, good, good. The axis of symmetry, I would like mine, not I like, you should draw it. The axis of symmetry is right here. Why would you draw it? Because it helps you produce another point. Gives you the quadratic. Right? Do we just draw it? Do we just draw things on our graph and what do we do?
Label.
You gotta label it. What do we label it? Yeah, but it's an equation, right? That's a vertical line. What's the equation of a vertical line? Leah? It's the x portion of your vertex. That's the axis of symmetry. Because the vertex is the halfway point between all your points, right? Splits the graph into two pieces. Okay? So if I had this point here, the y-intercept, this kind of gets at the heart of the partial factoring process. That's why I asked you to produce a graph. That's why these lessons, this is why these two topics were on the same lesson. You know another point on that graph because of the symmetry in it. That's the heart of the partial factoring process. You know that that point is 1, 2, 3, 4 away from the axis of symmetry. So I'm going to go to the same height at 7. I'm going to go 4 on the left. 1, 2, 3, 4, right here. 3 points. That's it. You got your 3 points. If I asked you for the roots, then yeah, you could plot the roots too. Right? But it's just a sketch of the quadratic. We just needed roughly what it was going to look like. Is everyone okay? That's a great question to get at, like, what we were doing with partial factoring, right? Trying to find the other point that's at the same y value as your y-intercept and what its x value was. We found what its x value was. It was x equals -8. When I substituted x equals -8, or I could have, it would have spat out 7. Okay, everyone okay? Okay, let's go down. Did a couple of these questions too. Okay, revenue can be defined as, oh sorry, first let X represent the number of $1 price increases. Okay, so revenue is always equal to the number of something you sell versus how much you sell it for. And so there's information provided in this question for both of those components separately. So the number, usually 300 students attend. So in the number portion here, we're going to have 300. And then we're going to have something happen to the number of kids showing up depending on how I play with the price, right? So we're going to lose 30 students, every time I increase the price by $1, X, that's what we define our variable to be. On the other hand, the amount of money we're going to make, we started at charging $8, and then I'm going to increase the price some number of times by $1, 8 plus X. Is everyone okay with the setup of that, the logic? Okay. Now you can do one of two things here, right? Like you can expand this out, partial factor or complete the square. That would be I think a poor choice to do this question because this is already written so that you can identify the axis of symmetry. If I set, it could be any revenue, but I think the easiest one to represent or solve for X is if the revenue is equal to 0. Look for the values of X where the revenue is equal to 0. Find the middle of those values of X. That's your axis of symmetry. That's half your vertex. That's half of what this question would be asking for. It'd be the number of price increases or decreases that optimize the amount of money being made. Right? If you found the middle. And then you could actually find what that ticket price would be by using that axis of symmetry in your equation. Right? So, we're going to go, just rewrite this. Okay. So either of these, both of these can equal 0, right? So 300 minus 30x is equal to 0. And 8 plus x is equal to 0. So 300 is equal to 30x. Divide both sides by 30. We get x is equal to 10. On the other hand, we can get x is equal to negative 8. Those are the two points in time, the number of price increases and decreases where this dance makes no money. If I increase the price by $10 and charge everybody $18 a ticket, we're not going to make any money. If I decrease the price by $8 to 0, essentially, because we started at $8, obviously not going to make any money because nobody's paying any money to come into the dance. You're not going to make any money that way. Does that make sense? The middle of those two X values, or price increase decreases, is where you're going to optimize the amount of money that you're making. So find the middle of them. That's what we call the axis of symmetry, right? That's going to be 10 plus negative 8 divided by 2, which is 2 divided by 2. So we could say $1 price increase optimizes revenue. Okay, what is that price? If you have $1 increase, you started at 8, that must mean $9 optimizes the revenue. And that's all it asked for. It didn't ask what the actual it didn't ask what the maximum revenue was, so that's it, you're done. It only asked for what ticket price optimizes the amount of money being made, not what the amount of money made was. Don't waste your time answering things that have not been asked of you. Time is a valuable asset in a test situation. Don't waste it. Okay, sometimes that means, it means don't answer things that haven't been asked of you, but it also means don't waste your time on something you're probably not going to figure out. Come back to it at the end. Go to the stuff that you know first. Do it. Okay? All right, let's go down. Find the points of intersection between this quadratic and a line. Okay? Well, where are they going to be? Where do they intersect? That's what we're going to try and figure out, the values of x. Okay, so what we're going to do is set them equal to each other. Okay, so we're going to say f of x is equal to g of x. So I'm going to go negative 2x squared minus 5x plus 20 is equal to 6x minus 1. How do I solve something that looks like that? You solve it the exact same way you've solved all quadratics in the past. You get 0 on the right-hand side. How do you get 0 on the right-hand side? Take 6x away and add 1 to both sides. So you're going to get negative 2x squared minus 5x minus 6x plus 20 plus 1 has to equal 0. And clean up the like terms. We're going to get negative 2x squared minus 11x plus 21. Okay? So we're okay? Karen?
Would you still get the same answer in the end if you did it the other way around, where you got rid of the quadratic and put it on the side?
Yeah, it doesn't matter if you choose to go plus 2x squared, it doesn't matter.
You get more positive numbers.
That's okay, yeah, you can do whatever you want. Like what we could do here, Karen, because I'm like, you can factor the negative out. Doesn't change the fact that you're looking for two numbers that multiply to negative 42 and add to negative 11. So I'm assuming you did it the other way. I think, yeah, it's nicer to not have the negatives in the equation, but it doesn't change the fact that I'd be looking for two numbers in either instance that multiply to negative 21 and add to negative 11. Sorry, negative 42. And add to negative 11. Okay. What are those numbers? If you don't know, let's go. It's 1 in 42, 2 and what? 21. 3 into 42. What's that?
14.
Is it 14?
Yeah, 14.
Yeah, sorry. Does that work? Yeah. So listen. So when I do these questions, I don't care about the signs at the beginning. I'm just looking for the numbers that work, like that I can visually think I can make work with the conditions. I'll worry about the signs after. One of them, if they're both negative, that gives me a product of a positive number. That's not what I'm looking for. So I know one of them has to be negative and one of them has to be positive. The question is which one? I think those are the two that are going to work here. Yes? Which one has to be negative in order to satisfy both conditions? The 14 has to be negative, right? Because 3 plus negative 14 is going to be the negative 11 that I'm looking for. Okay, so from here, what kind of trinomial is this? There's 3 options: simple, perfect square, or complex, right? This is complex because the coefficient on x squared is not 1, right? And so with the complex trinomials, I needed a process, right, called decomposition. I'm breaking the middle term down into okay, and then I selectively or factor by grouping. I group the first half, group the second half, common factor out of each half separately, and I should see a common factor appear in both halves, which then I can remove. Okay, so I'm going to get negative 2x should be left here, and I'm going to have x plus 7 plus 3x plus 7 has to equal 0. And so I get x plus 7 multiplied by negative 2x plus 3 has to equal 0. So one of these x values is going to equal -7. The other one we'll actually do a little bit of work on. Three by 2. Owen?
So I did it wrong the second time, and I got this answer still right. I added 6x by accident. So I got -2x squared plus 1 equals plus 21 plus 1x plus 21, and I still got x equals 2/3 and x equals -7.
What were the factors that you found?
I found factors were +3 and +7. So I went, it was negative.
Yeah, but does that check that out is what I'm saying.
No, well, I had to multiply -42 and add to 1.
But it's not 1, it's -11, right?
But it's not 1, it's -11, but I did it wrong. And not 1.
Well, I think you've done maybe 2 things wrong, coincidentally gotten something then, I don't know.
Yeah, I don't know.
Because it should be -11.
I know it should be -11, I said I did it wrong
Alright.
at the start.
We'll look at that.
That's weird.
Okay, says find the points. What have I found?
You don't have to divide. Never mind.
No, there's no vertex, but this what I'm gonna find the actual points of intersection, right? I have like an x1 and an x2, but points have what in them? Robbie?
Y coordinates, and also you forgot to carry the negative in the -3/2x equals x. That's because you don't.
No, I moved the -2 over to the other side. Right here.
That makes no sense.
Okay, I added 2x. I just dealt with the negative instead of bringing the 3 over and dealing with 2 negatives. I just got rid of the negative by bringing it over. Okay, so Robbie's right. Those points need y values associated with them, which is what we're going to find, okay? So I need to find, if this is x1 and x2, I need to find y1 and y2. I mean, the good part of this is that you've already done all the hard work. I think we're just finishing the question off now. Okay, which of the 2 equations are you going to use? Doesn't matter. Gabe? I would use the linear one. I wouldn't use the quadratic one. Right? So y1 is going to be the product, or sorry, not the product. It's going to be the result of taking your x1 and substituting it into the g of x function, right? And so for y1, I'm going to evaluate the g of x function at -7. And I'm going to see that 6 times -7 minus 1 is going to equal -43. So there's 1 point, -7 and -43. If I do y2, I'm going to evaluate the g of x function at 3/2. Okay, why do I like fractions? Because they hold all the information in them. And actually, when I evaluate here, it's not so bad. Because I'm going to have 6 times 3/2 minus 1 is 6 divided by 2 is going to be 3 times 3 minus 1 is 8. Why did I do 6 divided by 2? Gabe? Okay, this is good. Say, like, we have to be able to do this in a couple days because we're gonna do it with polynomials, not numbers anymore, which is gonna become imperative for you to be able to simplify fractions. So this is actually still equal to 6 divided by 2 times 3/1. Because when I multiply fractions, I just multiply the numerator times the numerator and the denominator times the denominator. And we know that the order in which I multiply things doesn't matter. So it doesn't matter if it's 1 times 2 here or 2 times 1, it's still 2. So I've strategically shuffled so that I can see the division happening. That's why I like working with fractions, because you never know what it is you're going to be able to divide out. Sophie?
How can you multiply the denominator but not the numerator?
When we multiply fractions, its numerators are multiplied separately from the denominator. So this would have actually been 18 by 2, which I can see, or minus 1, which would have been the 9 that I would have gotten from the product of 3 and 3. Okay, there's your points. -7, -43. There's a lot of talking for a lot, like for quizzes that were predominantly blank as I was looking at them. So, got another question to do, which you're responsible for on Monday. Okay. Determine the value of k such that g of x intersects the quadratic. Are you guys done? Because I'm almost done. I already know how to do this question. I think you don't, is my impression. But you're telling me you do. So, you can understand my confusion. Okay. This requires you to know that the discriminant is b squared minus 4ac. Okay, we are looking for the value of k. Where do I make the y-intercept on the linear graph so that it touches the quadratic in exactly 1 point? What do we call that? Either tangent or secant. Which one is it? It's the tangent one. If a line touches a graph in exactly 1 spot, that's called a tangent.
Are you going to give us that equation?
Absolutely not. Take the training wheels off. Let's go. You did a whole course. You wrote an exam. You should know that it's b squared minus 4ac. That's like asking me for the revenue. You're gonna ask me for that. Come on. Do so. At no point, like, that should be in your head. You should have done enough questions for that to be in your head now, right? Come on. But it's not. It's a good telling sign that you haven't done enough, right? Okay, so the discriminant, what's true about the discriminant out of the context of this question if we only have one root? It's equal to 0. So, you know 0 is going to equal b squared minus 4ac. Okay? In this specific instance where this is for 1 point of intersection. Okay? So, here's what we need to do though. Just like the last question, you're going to set them equal to each other. Okay? And then shuffle everything over and set it equal to 0. Okay? So, we're looking for, again, where the line and the quadratic intersect. We're just looking for the specific instance where there's only 1 point of intersection. So f of x is equal to g of x again. So I want you to ask yourself whether or not, like, what's the difference between number 3 and 4? And you can probably imagine as to which one I'm going to ask you, because they look very similar, do they not?
Yeah.
So which one do you think I'm going to ask you? If the concept looks to be about the same, and we're in the context of a shorter test, and I can test multiple concepts in one question, which one do you think I'm going to give you?
3.
Like 3? You think I'm going to give you 3?
3 have to be more.
I'm going to give you 4.
Oh, he wants to be shorter. No, he wants
to combine.
I want to combine topics into questions. This has a couple it has this idea of a line intersecting a quadratic, as well as what value of k would make that happen. And I get to loop in the discriminant in that question. So if I had to pick a question to put on the test, I'd probably pick one like number 4. Especially in a time constraint and a length constraint for a test, right? So this is going to be, make sure I just wrote everything down right. We're good. 2x squared minus 5x plus 3 minus 3x minus k has to equal 0. So you're going to get 2x squared minus 8x plus 3 minus k is equal to 0. Okay. Everyone happy with that? Let's identify, for the purposes of our discriminant, B, A, and C. A, B, C.
Where did the 3x?
3x. Oh, sorry. I brought it into 5x and negative 3x. So it became negative 8x. Sorry, you had me for a second. I thought I left the x off. Okay, so substitute that into your discriminant. You should see that there is nothing left except for k to solve for. Okay? So 0 has to equal the b value, which is negative 8 squared, minus 4 times 2 times c is 3 minus k. So 0 is equal to 64 minus 8 times 3 minus k. Bring the 64 over, minus 64 from both sides, 0 pair it. Divide by negative 8. We get 8 is equal to 3 minus k. Take 3 away, take 3 away. I get 5 is equal to negative k. K is not by itself yet. Divide both sides by negative 1. Listen, if you write a therefore statement like this, and I look at that, I'm going to go, so-and-so knows exactly what they have just found and what they are doing. A lot can be inferred from how much communication you put into your therefore statement. Okay? Look at all the information I'm writing down here. The k value, I'm making a connection with past knowledge. It's a line. It's the y-intercept. The y-intercept for the line so that it intersects the quadratic. So the line becomes, or g of x, I suppose. What was the slope? 3x.